Good morning, intelligent friends. I am Abhijit Barwani from Class 6C of CMS Shop campus, and today I am going to discuss with you all the chapter sets in mathematics. So let's start. In our daily life, we often speak or hear about different types of collections, such as a collection of books, a collection of flowers, a collection of movies. In the same way, we have different types of groups made for different activities. For example, a group of boys playing hockey, a group of girls playing badminton, a group of students preparing for annual function. So, how do we define a set? A set is a collection of well-defined objects. Now the question arises, what is well-defined? Well-defined means it must be absolutely clear that which object belongs to the set and which does not. April, June, September and November belong to the set of having months having 30 days. However, February does not belong to this group. This is a well-defined group, so it is a set. However, all difficult triangles to draw does not constitute a set, as difficult concept varies from student to student. It might be difficult for me, but might be difficult for Virat. It is denoted by a pair of curly brackets denotes a set. Elements or members of a set. The objects used to form a set are called its elements or its members. Properties of a set. All the objects of a set must be different. None of the elements should be repeated in a set. If X is an element of set P, we write X belongs to P. The symbol epsilon is read as belongs to. If X is not an element of P, we write X does not belong to P, which means X does not belong to P, or we can also express it as X are not an element of P. The change of order of writing elements does not make any change in the set, which means if it is written June, September, April and December, even then the above set will remain the same. Standard sets of numbers. The set of odd numbers is written as O equals to 1, 3, 5, 7, 9, 11 and 13 and so on. The set of even numbers is written as E equals to 2, 4, 6, 8, 10, 12, 14 and so on. Representation of a set. There are following methods of representing a set. Description method, roster method, set builder form. Description method. In this, well-defined description of the elements of the set is given and the same are enclosed in curly brackets. It is also known as statement form method because the elements of a set are described in statement form. For example, the set of odd numbers less than 7 is written as odd numbers less than 7. A set of football players with ages between 32 years to 30 years is written as football players between 32 and 30 years. A set of numbers greater than 30 and smaller than 55 is written as numbers greater than 30 and smaller than 55. Roster form or tabular form. For example, in this elements of the set are listed within a pair of brackets and are separated by commas. Let's n denote the set of first 5 natural numbers. Therefore, n equals to 1, 2, 3, 4 and 5. The set of all vowels of the English alphabet. Therefore, V equals to A, E, I, O, U. The set of odd numbers less than 9. Therefore, X equals to 1, 3, 5 and 7. The set of all natural numbers which divide 12. Therefore, Y equals to 1, 2, 3, 4, 6 and 12. Note: the order in which elements are listed is immaterial, but elements must not be repeated. Third form, the set builder form. In this, a rule or the formula or the statement is written within the pairs of brackets so that the set is well defined. In the set builder form, all the elements of the set must possess a single property to become the member of that set. In this form of representation of a set, The element of the set is described by using a symbol x or any other variable followed by a colon. The symbol this or this is used to denote such as then. We write the property possessed by the elements of the set and enclose the whole description in braces. In this, the colon stands for such that and braces stands for set of all. For example, let P is a set of counting numbers greater than 12. The P in set builder form is written as P equals to x colon x is a counting number and greater than 12. Or P equals to x and x is a counting number and greater than 12. This will be read as P is the set of elements x such as x is a counting number and is greater than 2. Well, note the symbol colon or the line is placed between two x stands for such as let A denote the set of even numbers between 6 and 14. It can be written in the set builder form as A equals to x and x is an even number. 6. The second condition is x is greater than 6 and less than 6 as less than 14. Or A equals to x colon x epsilon p. 6 is x is greater than 6 and less than 14 and p is an even number. If x equals to 4, 5, 6, 7, this is expressed in roster form. Let us express it in set builder form. X is a natural number and x is greater than 3 but less than 8. The set of A of all natural numbers can be written as x is a natural number and x equals to 2n plus 1 for n epsilon w. Example using three methods of representation of a set. The set of integers lying between -2 and 3. Description or statement form. I is a set of integers lying between -2 and 3. Roster form. I equals to -1, 0, 1 and 2. Set builder form. X colon x belongs to I, which is or second condition x is greater than -2 but less than 3. Finite set. A set which contains definite number of elements is called a finite set. Empty set is also called a finite set. For example, the set of all colors in the rainbow. N equals to x colon x belongs to n, which is x less than 7. P equals to 2, 3, 5, 7, 11, 13, 17 and till 97. Infinite set. A set whose elements cannot be listed, that is, set containing never-ending elements is called a finite set. For example, set of all odd numbers. A equals to x colon x is a natural number and x equals to 2n plus 1 for n belongs to w. Set of all prime numbers. B equals to x colon x which belongs to w. X equals to 2n. Note, all infinite sets cannot be expressed in roster form. For example, the set of real numbers since the elements of this set do not follow any particular pattern. Empty set or null set. For example, a set of whole numbers less than 0. Clearly, there is no whole number less than 0, therefore it is an empty set. Let A equals to x colon 2, x is greater than 2 but less than 3. S is a natural number. Here A is an empty set because there is no natural number between 2 and 3. Let B equals to x colon x is a composite number less than 4. Here B is an empty set because there is no composite number less than 4. Note, the symbol this equal not 0 has no element. 0 is a set which has one element, 0. Now we will study non-empty set. A set which does not contain at least one element is called a non-empty set. For example, the set of whole numbers less than 2 equals to 1. B, n equals to x colon x which belongs to n. than the second condition. X is greater than 3 but less than 5. Singleton set. A set which contains only one element is known as a singleton set. For example, A equals to x colon x is neither prime nor composite. It is a single set containing one element, i.e. 1. B equals to x colon x is a whole number which is 1 is greater than x. This set contains only one element 0 and it is as a singleton set. Let A equals to x colon x which belongs to n and x into the power 2 equals to 4. Here A is a singleton set because there is only one element 2 whose square is 4. Let B equals to x colon x is even a prime number. Here B is a singleton set because there is only one prime number which is even, that is 2. Cardinal number of a set. The number of distinct elements in a given set A is called the cardinal number of A. It is denoted by NA. For example, A equals to x colon x which belongs to n and that is x is less than 5. X is a set of natural numbers and x is less than 5. Therefore, A equals to 1, 2, 3, 4. Therefore, NA equals to 4. B. Set of letters in the word algebra. B equals to A, L, G, E, B, R. Therefore, N, B equals to 6. Thank you.